Hello, today we have the episode number 12, where we are discussing with Tímea Tatár-Kis about the protection against very virulent and variant IBDV strains. Enjoy! Hello poultry friends, we are today in Budapest, Hungary, in Ceva Philaxia campus. It's a place with a really long history, more than 100 years, not just producing vaccine, but doing research and producing a lot of knowledge for the poultry industry. I'm proud to receive today Tímea Tatár-Kis that perform a really important role in the company that we are going to disclose a little bit today. So welcome to Turning with Experts.
Thank you, Marco, and thank you for the invitation. Welcome in Hungary.
So, first of all, can you disclose a little bit about your main activities?
Yes, of course. I'm working on scientific investigations related on poultry vaccines against viral diseases. One of them is Gumboro Disease. This means that we are running studies to understand the diseases better and also to understand more the differences between different vaccine technologies. This activity is run within the Scientific Support and Investigation Unit, which has a quite unique setup because we are involved in the diagnostic and disease awareness activity of Ceva on one hand side. And from this, we have a view on what's going on in the field. Also, we run a lot of molecular characterization of different viruses. And in case we find something really new and interesting, due to the strong link between the diagnostic activity and the research activity, we can have a deeper look. We can run pathogenicity testing, serological characterization as well to support this diagnostic activity. And there is also a big benefit of this setup that we can use the isolates as challenge viruses in vaccine efficacy studies, so we can generate information against a wide range of viruses for different diseases. I really like this way of working. I think it's really inspiring.
Yes, not just inspiring, but I know that's contributing a lot for the poultry knowledge. As you said, understanding better the disease, that's something extremely important to be able to control. And going on this topic, I know you are involved on the research, but as well you are connected with the lab diagnosis. So I would like to see from your point of view, how is the Boomboard challenge along the years? How is your perception regarding that?
Nowadays, the very virulent Gumboro viruses are being more and more well controlled through vaccination. So now I think that the focus is more on less virulent subclinical strains that can be found in different places of the world, and that can cause also an immunosuppressive effect. So it is not only about having high mortality due to Gumboro disease. Any kind of Gumboro viruses can bring losses for the poultry industry, and it is important to control not only the very virulent viruses, but also the subclinical strains in the field. And currently what is changing, what is popping up regularly is the detection of different genetic groups of subclinical strains, which are sharing the same pathogenic feature, let's say, but they are not only genetically different, they have some serological differences as well.
And how do you see that it can impact the perception of the IBD pressure?
I think it is really important that the perception is not really what is the reality. It is how we feel, what is the situation. And this can be influenced by several factors, because originally when very virulent IBDV was widespread, then the people started to think about Boomboard disease as a very severe disease with high mortality. Now, since it is usually not there, they have the feeling, they have the perception that there is no issue with Gumboro disease. But if we consider a few factors that I would like to highlight now, then we can see that this can be a kind of hidden enemy present in our world. For example, if we run a challenge study in commercial broilers with a low MDA level, with very virulent IBD virus in a controlled, clean environment, we hardly see any clinical signs and mortality. This is due to the bigger resistance of broiler breeds to the very virulent viruses, to the development of clinical signs, but also due to the clean environment and the moderating effect of this residual MDA. There is another example, which is the opposite. It was in commercial layers, but without MDA, which were infected in the field with a strain that is a subclinical strain, but they had high mortality and severe bursar lesions that would indicate the presence of very virulent IBDV. And this was due to the co-infection of infectious anemia. So I think it is really important to run laboratory testings to identify what's going on in the field, not just focus on the clinical signs and bursar lesions and seroconversion. And there is a third example that I would like to share. It's about the dose effect in the clinical outcome of Gumboro disease. In our experiments, when we are changing only tenfold the challenge dose of very virulent IBDV, we can face a strong change in the pathogenicity. We can have high mortality or no or very limited mortality with the same strain. So it is really important to control the amount of field viruses in the farms to have a calm situation for Gumboro disease.
Moving now to the knowledge that you acquired after several trials that you conducted here with Boomboard disease challenge with very virulent, with different strains. What, from your point of view, is the key points to control the disease?
For me, there are three key points. One of them is cleaning, disinfection, and the proper downtime to reduce the virus load in the environment. The second one is the improvement of the bird's resistance by vaccination, which will also contribute to the reduction of field virus load in the environment. And the third one, which is also the key, is the vaccine administration. We need to have a proper flock coverage by vaccination to enjoy the benefits of vaccination.
Depending the type of virus that we are talking about, it can change.
The basics are the same for all different IBD viruses, but there can be some adjustments in the vaccination program of the breeders and the progeny to have the best vaccination program depending on the different field viruses present in the farms.
As I mentioned, you are run several trials. Can we have some outputs from these results that brings to us some experience about this to help us on these key points of control?
From these studies, what we can see is that in case of live vaccines, both immune complex drinking water and in case of the recombinant vaccines as well, there is no so strong effect of the field virus on the vaccine performance. I mean that there is no need to update the viruses on a regular basis just because there is a new variant detected in the field. Mostly these vaccines provide a broad spectrum of protection in case of Gumboro disease. This is what we saw using different challenge viruses.
And another point that it was done along the years is the studies comparing the potential protection between different technologies. So I'm talking about conventional field vaccines or the fields or the vaccines applied in the hatchery as the immune complex or the vector vaccines. From your experience, what we can expect from each of them?
One group of them is the live vaccines and the immune complex vaccines from the aspect that both of them contain a live vaccine virus, which will replicate in the bursa very extensively, and through this, both of them will induce a very strong and rapid immune response, which will be broadly cross-protective. The big difference between these two is that drinking water vaccines must be applied at the proper age when the MDA level declined to a certain level. And to reach this, we need a regular monitoring of the flocks to know the exact MDA level in a given flock and adjust the vaccination time accordingly. In case we apply the vaccine too early, then it will be neutralized by the MDA. If we apply it too late, then we leave a wide window open for the field viruses. And this is really a difficulty of drinking water administration. There is another aspect here that several cases the flock is quite heterogeneous in terms of MDA level, which cannot be handled with a single vaccine administration. Depending on the drinking water vaccines, 2 vaccinations might be required to cover the whole flock. The benefit of immune complex vaccines is that they can be administered in the hatchery, either in ovo or by the subcutaneous route. And after that, there is no virus replication in the bursa starting within a few days, but the vaccine virus waits. It waits until the MDA decays to a required level. So we can say that there is a built-in MDA decay detection system in the immune system, in the immune complex vaccines, and it will adjust the vaccine take in each individual to the proper MDA decay level. When when the MDA reached a low level, which is required for vaccine take, then the vaccine virus will reach the bursa and start replicating, and from this point it will act exactly like a live drinking water vaccine applied at a proper age. So it will bring a broad spectrum and strong immune response. And after this very strong immune response, the birds are so strongly protected against IBDV infection that there will be no reinfection occurring after this vaccine take. The recombinant HVT-IBD vaccine is a different type. In this case, the turkey herpes virus is the vector, which expresses the VP2, the key protective protein of infectious bursal disease virus. It means that it will have a different cell tropism compared to the live Gumboro vaccines, and it will induce a different immune response. It will be progressively developing a slower immune response that will end up with a lower humoral antibody level.
So you mentioned that the live IBD vaccines are going to be able to colonize the bursa and this way block the replication. Is it means that once it's occupied, once the vaccine virus start to replicate in this bursa, it will be blocked for any type of other Boomboard virus?
Yes, our experiences show that after there is this extensive virus replication from the vaccine in the bursa, this bird is completely protected from any subsequent IBDV infection and shedding.
When you do a comparison, for example, for the recombinant vaccines that are using a VP2, how is going to be the protection against different type of virus?
The effect of differences in the challenge virus are stronger in this case because, as I told, in live vaccines and immune complex vaccines, regardless the challenge strain, we see this complete blockage of virus replication in the bursa. In case of the recombinant HVT-IBD vaccines, where there is only the VP2 included, we see that they are more prone to the differences in the challenge virus. Some variants can be quite well controlled, others are less properly controlled if the VP2 of the vaccine is a classical type. So in this case, there is a bit more need of better matching, but still there is a cross-protective ability of this vaccine type. The best one with the strongest and broadest protection is the immune complex or the live vaccine if it is taken properly.
Of course, we can understand from the live IBD vaccines, one of the most important parts that's going to replicate in the bursa, and this way protects against any type of other infection. What can be the effect when they are using conventional live vaccines in the farm and part of the flocks not covered?
Basically, this virus can spread quite efficiently, but I don't know in farm situation what happens. In our studies, when we have an unintentional IBD introduction, it used to spread very easily through across the flock. But in field situations, for me the key is that in case there is a lot of birds left out in vaccination, then even if horizontally they will be covered, it will take time. And Gumboro protection is a kind of race between the field viruses and between the vaccine viruses. So in case we are applying a drinking water vaccine with a very limited success level, and it takes 1 week or 2 weeks to cover the whole flock, then we may lose this battle against the field viruses just because of this delay.
So, Tmea, when you talk about new findings, new research or new publications that are being published, what we can disclose to us?
For me, it is really interesting to see more and more publications about reassortant IBDV viruses in Europe, which are gaining a bigger spread throughout the years. And these are really interesting in terms of scientific knowledge, because we learn more about the importance of reassortment itself and the importance of special mutations. From the apart from the scientific part, for vaccine protection and all the Gumboro disease control approaches, I think it is not something new. We do not need to change very much our approaches, because the currently used ones against subclinical strains can work properly against these viruses. But is also popping up sometimes as new the detection of different subclinical groups, subclinical strains that were not described before in the literature. Some of them are really new, but some of them were there 20 years ago or 10 years ago when we were involved in surveys in Europe or outside of Europe. So I think these new findings of some variant strains, sometimes they are really new, but a lot of them is the new isolation, new detection of a genetic group by new groups of scientists that were already there years ago.
To close our conversation, if you want to advise the vets about controlling Boomboard disease, what would be your advice for them?
My advice is to support their decisions by meaningful laboratory results. I think that the first point that they must be aware of the current epidemiological situation in their farms, and also about the efficiency of the current vaccination methodology, what they use. And after that, they can make a smart selection of the proper vaccine type that is expected to bring the good flock coverage, also the expected level of Gumboro disease control, which can be introduced into their vaccination program properly.
So, Tmea, I would like to thank you first to accept our invitation, to share your knowledge with us, your experience with us, to welcome the TANINF experts in Budapest, in Hungary, and thank you for all your collaboration for the poultry industry.
Thank you, Marco.
Okay, so with that, we close for today. Keep TANIF with us. Bye. Thank you for watching this episode. And do not hesitate to give us your feedback by commenting down below in the comment section. Goodbye, stay safe.